Hello and welcome to a new video. This is for Algebra 1. This is lesson 4 of Unit 8, which is all about solving quadratic equations. And we're going to wrap up this idea of solving quadratic equations by saying when do we use each method, or how would we decide when to use which method or whatever. So when we did systems of equations and we had 3 methods that we could use, any system we had, you could actually solve by any method. But some were harder than others to solve by a particular method. This is different because, what we have with these 3 methods, which there are actually a couple other methods that we're not talking about right now, but what we have with these 3 methods is we have a method that only works some of the time, a method that only works some of the time, and a method that works all the time but is more effort than the other 2. So it's all the more important for us to understand when we can use the shorter, faster methods so that we can avoid using the longer method, when we don't need to. And so if in the previous lesson, sorry, my eye is so itchy. In the previous lesson, if you notice as we went through, anytime we ended up with a nice answer, that's actually something that we could have done by a different method. So let's look at basically a reminder of what are our 3 methods and when are we going to use them. So the first way we did in 8.1 was square roots. And so square roots only works if there is no regular x term. So if you have x squared, but you don't have an x, so something like x squared minus 9 equals 0. There's an x squared, there's a number, but there's not a 5x in there throwing us off. So we're allowed to get x squared by itself as though we were solving it like a normal equation, and then square root each side. And don't forget that that gives us a plus or minus. Factoring only works when we can factor. So factoring we would use when we notice it's factorable. And that's really the issue here, right? Is that we're new to factoring. It may or may not be going particularly well, depending on you. And so you may be like, I would never in my life notice that something is factorable, and that's fair. But hopefully, eventually, that'll be something that you're like, oh yeah, I either have to use the quadratic formula or I have to be able to factor this, and hopefully factoring will stick in your head. Quadratic formula is our can use anytime. And so you could, if you wanted to, be like, well, I'm just going to use the quadratic formula all the time no matter what, because I know it works no matter what, and that is technically an option. I don't think it's a great option, but it is an option. So I've got 4 examples for us here, and you may be thinking 4 examples, but there's only 3 methods. But that way I can maybe throw you off as far as, the whole process of elimination thing goes. We're going to look through and see if we can figure out when would we use each method. So example 1 here, x squared minus 6x plus 4. Can't use square roots. That automatically goes out the window as we have a negative 6x. So even if I could get x squared by itself, I'd still have this other x floating around somewhere. Well, I can get x squared by itself, but the other x would be a problem, is what I'm trying to say. So that's not going to work. Can I factor this? So since there's not anything in front of x squared, we don't have to do something fancy like slide and divide or the box method. We just need to think, is there something that multiplies to get 4 that adds to get negative 6? And the answer to that is no, there's not. So right off the bat here, actually, we're going to use the quadratic formula. So everything is on the left side and it equals 0. So A equals 1, B equals negative 6, and C equals 4. So then we're going to plug it in. I've got the quadratic formula off the side. You may be thinking, you totally gave it away because the quadratic formula is right there, but it should be on every slide. It was there just in case we needed it. X equals negative B plus or minus square root b squared minus 4ac all over 2a. I hope you enjoyed that as much as I did. So negative 6 turns into positive 6. You're welcome to just write that right off the bat instead of writing the negative 6 if you want to. Then we're going to do negative 6 squared, which is 36, and negative 4 times 1 times 4. That 4, by the way, is a part of our formula. It's what makes this work out. This 4 and this 2, those don't ever change. Later on, once you've learned a completely different method for how to solve these, we'd be able to go through the process of like showing how you can get the quadratic formula, but it's kind of complicated. So the 4 and the 2 just are there. Negative 4 times 1 is negative 4. Negative 4 times 4 is negative 16. All over 2a, so 2 times 1 is 2. Now we're going to do 36 minus 16, which is 20, and then we're going to say, well, 20 is not a perfect square, which it shouldn't be, because if it was a perfect square, I would have been able to factor it. So we need to simplify this. So I need to say, what does 20 split up into? Well, it splits up into 5 and 4, and I can square root 4, which means this is 2 square roots of 5. So 6 plus or minus 2 square roots of 5 over 2. And then we look at everything except for the actual square root. And we say, do all of these numbers, so the 6, the 2, and the 2, do they all divide by the same number? And if they do, we divide them all by that number. So this would turn into 3, this would turn into 1, this would turn into 1. So since it would be 1 on bottom, we don't need a fraction anymore. And we actually don't need the 1 in front of the square root of 5 anymore either. The answer to this is 3 plus or minus the square root of 5. If you happen to know how to complete the square, which is one of the other main methods that we usually do for solving quadratic equations, this would be an easy one to complete the square on. I guess I could have said that at the beginning so that you could have practiced that, but I prefer to kind of hold off on completing the square for time's sake. So yeah, let's look at another example. Example 2. So can we use square roots on this one? The question is there an x term? There is, so we cannot use square roots. What about factoring? If this factors, we would have to use slide and divide or the box method, and both of those or split the middle term. And all of those methods require us looking at 4 times negative 6 and saying, is there something that multiplies to get this number, negative 24, but that adds to get negative 5? Or since this is a negative 24, it'd be more like it subtracts to get negative 5. So 8 and 3, so negative 8 plus 3 would work. I'm going to go ahead and, I guess, make the box. So 4x squared and negative 6, and one of these needs to be negative 8x, and one needs to be 3x. And then we look at the top two and say, what do these have in common? And we look at the bottom two and say, what do these have in common? Look at the left two, what do these have in common? And the right two, what do these have in common? And then that gives us our two parentheses, x minus 2 and 4x plus 3. Do a double check here to make sure that I haven't messed this up, because that would be unfortunate. Yep, I just foiled it in my head real quick, so be impressed. Or not, it's whatever. We're not done yet though. We factored it. Now we take each of these parentheses and we say, well, if two things multiplied together equals 0, then one of these has to be 0. And that's how we end up with our two answers. So I'm going to add 2 to both sides to get x equals positive 2 for one of my answers. The other answer, I have to subtract 3, and then I need to divide by 4 and get x equals negative 3/4. An interesting note on slide and divide, by the way. So for slide and divide, which is a method that not all teachers actually like, or mathematicians, I guess, like, because you slide the 4 over, and that's not actually something that we're allowed to do mathematically, just to be clear here. Then we'd say, what multiplies to get negative 24 and adds to get negative 5? And we'd write it like this, and then we divide by the 4 that we slid earlier. And what's interesting about this method is that if we look at what these parentheses simplify to be, okay, x minus 2 was the right thing. But notice how this, like, if you simplify, it's still 3/4. And notice how our answer ended up being negative 3/4. So if you're using slide and divide, that's something you'll probably notice. And so I didn't want to just like ignore that that was a thing. It is. Just know that like this step right here, this is not equivalent to 4x squared minus 5x minus 6. We've done a trick that technically makes this not be equal, but it does give us the right answers if we see it all the way through. So I just thrown that out there. Let's look at example 3. Okay, we don't have an x term. That's nice because we can use square roots. Now I was a little mean on this one with our numbers here. We're going to add 9 to both sides and get 4x squared equals 9. You could square root at this point. I prefer to go ahead and get all the way to where x squared is by itself. And I think that that is the way to be less likely to make a math error. Then we square root once x squared is by itself. And so that gives us a plus or minus because we've square rooted in an equation. And so we have to think there's actually two things that when we square it gives us a positive 9/4, a positive and a negative. And then the square root of 9/4, you square root the top and bottom separately and get 3/2. So x equals plus and minus 3/2. See, now wouldn't that have been terrible to use the, well, a lot more terrible to use the quadratic formula on, because what would happen, by the way, is since we don't have an x term, that would be b. So we'd have a equals 4, b equals 0, and c equals negative 9. And we'd plug it in, and it'd be fine, like we'd work it out, and it wouldn't actually be that hard, but it would be, in my opinion, more work than what we just did. So, just thought I'd throw that out there. Now, example 4, you can't use process of elimination here to try to figure out what it is. What in the world could this be? Is this solving by square roots? Is this factoring? Is this the quadratic formula? What do you think? Don't look at me. I'm asking you. Well, what do you mean I can't hear you? Why don't you just put it in the comments below? Tell me what method it is you think we should use. I'll wait. No, seriously, put it in the comments. Okay, fine. All right, so it's not square roots because there's an x term. So next we check factoring. Unless you're the type of person that's like, I would rather just go ahead and use the quadratic formula instead of bothering trying to factoring. But on this one, if we look and say, okay, what multiplies get 1 and adds get 2, there's only one option of what multiplies get 1. That's 1 and 1. That happens to add to get 2. So this actually does factor. And in fact, the other reason I did this is because this gives us a rare situation here where these are the same parentheses. So we actually get the same answer twice. X equals negative 1 is what we get from both of these parentheses. So I may have mentioned before, there's this thing called the fundamental theorem of algebra that kind of indirectly ends up meaning that whatever the power is here, the highest power, x squared, in this equation, that's how many answers we should have if we include real and non-real answers. And so then when we have something like this where we have x squared, should have two answers, but we just get negative 1. Well, the way to kind of get around that is we're getting negative 1 twice. We're getting negative 1 from each of these sets of parentheses. So we got two answers. It's just the same answer 2 times. It's kind of a weird situation, but you know, I thought I'd throw it out there because it's one of those things that you can rely on the vast majority of problems to end up with 2 answers. And that's how you can be like, okay, I'm just going to go through like my test or quiz on this at the end and check to make sure that there's plus and minuses or 2 answers on everything because I know there should be 2 answers on everything. While if you end up with a situation like this, you wouldn't want to put a plus or minus because it's not positive 1 and negative 1. It's that we actually get negative 1 twice. It's really weird that it happens that way, but it does. So that's that example. And see how fast that was? Who would want to use the quadratic formula instead of doing this beautiful math right here? I would say very few people, but maybe I'm wrong. I don't know. Hey, thanks so much as always for watching. I hope you liked the video. I hope you actually liked the video. There's this thumbs up button that you might be seeing below the video that you could just, if you click it, or as the kids say, if you smash it, or whatever, like that would be super cool. Subscribe if you're not already, and I'll see you in the next video. We don't have a whole lot more left. We're getting towards the end of Algebra 1, so that's exciting. So I'll see you. Bye.